Welcome to qnawire.
In this problem, we have a car that is about to cross a bridge that is 500 meters long. The car started from rest, as such its initial velocity, let's denote as v sub naught x, is equals to 0. The car experiences a friction force opposite its movement with a coefficient of 1. Now, the problem asks us to show that the time it will take to reach the end of the bridge is not less than 10 seconds. In order to solve for the time, we need first to know the value of the acceleration of the car as it moves. To obtain an expression for the acceleration, we will use Newton's law of motion. So let's draw the forces acting on the car. First, its weight pointed vertically downwards. Perpendicular to the surface is the normal force, pointed vertically upwards. The frictional force pulling it towards the opposite direction. Let's denote this as F sub k. And the applied force, let's denote as F sub A, which is the force that is applied to make the car move. So in this case, since the car is now moving, the type of friction acting is kinetic, called kinetic friction force. Now let's write the forces into vertical and horizontal components. First, for the vertical components, the summation of these forces, let's know as F sub y, is equals to 0, since according to the first law of motion, a body in equilibrium, the summation of its forces, or the net force, is equals to 0. As such, 0 is equals to normal force plus the negative of the weight of the car, since it is opposite the direction of the normal force. We know that weight is the product of the mass and the acceleration due to gravity. So we can simplify the equation to normal force is equals to mg. Now for the horizontal components, summation of forces F sub x is also equal to 0. And the forces on this plane are the normal force plus negative of the friction force, since it's opposite the direction of the applied force. From second law of motion, it states that the force is equals to the product of the mass of the body and the acceleration due to its movement. Let's denote as A sub x. This is the value we are looking for. And the formula for friction, it is just product, the coefficient, and the normal force. We already know from the vertical components that normal force is just equals to mg. So the equation becomes simplifying, then acceleration is just equals to product of the coefficient of friction and the acceleration due to gravity. Since the value for the coefficient of friction is given, then we can solve for the acceleration. So 1.0 multiplied by the acceleration due to gravity, which is 9.8 meter per second squared. Then the value of acceleration A sub x is equals to 9.8. Now we know the acceleration of the car. We can use this value to solve for the time it takes to reach the end of the bridge using the displacement equation, which is x is equals to x sub naught plus initial velocity multiplied by time plus 1/2 multiplied by the acceleration times t squared. Since it starts from rest, then x is equals to x sub naught is equals to 0. As well as its initial velocity is also 0. Then this reduces the equation of the distance to x is equals to 1/2 a sub x t squared. Since what we're looking for is the time, let's move it to the left side of the equation. So t just equals to square root of 2 multiplied by the distance over the acceleration. Inserting in this equation the given values we have, then 2 multiplied by the length of the bridge over the acceleration we calculated. Solving, and the answer is t is equals to 10.1 seconds. Therefore, the time that it takes to reach the end of the bridge, the 500-meter long bridge, is always greater than 10 seconds.